A-Level Maths Paper 1 is fast approaching, so here's 2018 Paper 1. Let's go. Given that theta is small and it's measured in radians, use the small angle approximations to find the approximate value of 1 minus cos 4 theta over 2 theta sine 3 theta. So we have to use our small angle approximations. We know that cos theta is approximately 1 minus theta squared over 2, and that sine theta is approximately theta. Okay, so all we have to do is plug these in to the given equation. Okay, so we have 1 minus cos 4 theta, plug in what we know. We have 1 minus, so instead of theta, we have 4 theta. So it's going to be 1 minus 4 theta all squared over 2. Perfect. And then looking at the denominator, we have 2 theta multiplied by, so we have sine 3 theta, so this will approximately be 3 theta multiplied by 3 theta. Now looking at the numerator, we have 1 minus 1, those will cancel out. Then we have minus 4 theta all squared over 2. Minus is going to be positive. So 4 theta all squared will be 16 theta squared, that'll be over 2. And then looking at the denominator, we have 2 theta times 3 theta. 2 times 3 is 6. Theta times theta is theta squared. So what do we have? Looking at that numerator, 16 divided by 2 is simply 8 theta squared. Then looking at the denominator, we have already 6 theta squared. The theta squareds will indeed cancel out, leaving us with 8 over 6. And we can simplify this fraction to get 4 over 3. And that's your answer to question 1. Alright, so question 2, we're told a curve C has equation y equals x squared minus 2x minus 24 root x. We have to find dy dx and the second derivative. Okay, so looking at part A, we can quickly rewrite this as y equals x squared minus 2x minus 24 times x to the power of a half. Whenever we're differentiating or integrating, we want to write things as x to the power of something. If something's in the denominator, you might use a negative power, for example. So differentiating this to find dy dx, simple differentiation, bring that power down to the front, take 1 off the power. So x squared differentiates to 2x, minus 2x differentiates to minus 2. Then we do minus 24 multiplied by half, so that's going to be minus 12. X to the power of half, take away 1, taking away 1 off the power, will be x to the power of minus a half. Now to find the second derivative, so that's d squared y over dx squared. Differentiate again, 2x differentiates to 2, our constant will disappear. Then we have minus 12 multiplied by minus a half. It's going to be minus times a minus, so it's going to be plus 6x to the minus 3 over 2, take 1 off the power. So part B, verify that C has a stationary point when x equals 4. So all we have to do, because it's verified, whenever you see verify, you can use the information they give you. We just have to plug in x equals 4 into our dy dx. What's a stationary point? This is when dy dx is equal to 0. So plugging in x equals 4 into dy dx, I'm looking here. We have 2 times 4 minus 2. Take away, I'm going to write this as 12 over, because it's x to the power of minus a half. That's the same as 12 over root x, okay? So it's the same as 12 over square root of 4, because we're plugging in x equals 4. This will be just expanding it out. 2 times 4 is 8. Take away 2 minus, so 12 over the square root of 4 is 12 over 2, which equals 6. Okay, so it's going to take away 6. This will give us 8 minus 8, which is equal to 0. Therefore, we do indeed have a stationary, quickly write this out, stationary when x equals 4. Okay, perfect. Looking at part C, we have to determine the nature of the stationary point, giving a reason for your answer. So to determine the nature, we are indeed going to use our second derivative. Second derivative is, looking over here, 2 plus 6x to the minus 3 over 2. Quickly just write that out. We have 2 plus 6 times x to the minus 3 over 2. So what do? We have to plug in x equals 4, and then we have to see whether it's positive, negative, determine if we have a minimum, maximum, or potentially an inflection. So going from here, we have 2 plus 6 times x to the minus 3 over 2. That's 2 plus 6. I'm going to do the same thing as before. I'm going to write it as 6 over 4 to the power of 3 over 2. 4 to the power of 3 over 2, you could put it in your calculator, or you could just do it in your head. So you have 2 plus 6 over, square root of 4 is 2, cube it to get 8. So that's 2 plus 6 over 8. This is the same as writing 2 plus 3 quarters, which equals 11 over 4, which is indeed larger than 0. Therefore, our stationary point, because we have a positive second derivative, our stationary point will be a minimum, is a min, because our second derivative when x equals 4 is positive. And that's the answer to question 2. Question 3, we're told that figure 1 shows a sector AOB of a circle with center O and radius r centimeters. The angle AOB is theta radians. The area of sector AOB is 11 centimeters squared. Given the perimeter of the sector is 4 times the length of the arc AB, find the exact value of r. Okay, so just use the information they give us. First of all, what do we know? We know that arc length is indeed given by, so in this case our arc would be AB. Arc length is given by r times theta. And we also know that our area is equal to half r squared theta, okay? So let's just plug in the information we know. We know that the area is 11 centimeters squared, so 11 will be equal to half r squared theta, times both sides by 2, we have that 22 equals r squared theta. We're going to have to use this later on in the question. What else do we know? The perimeter of the sector is 4 times the length of the arc AB. So the arc AB, as we established, is r times theta. And then we told that the perimeter of the sector, is 4 times of the length. Okay, so the perimeter of the sector, just looking at the perimeter, we have r plus the arc length. Perfect. So perimeter is 2r plus r times theta. This will be equal to 4 times the length of the arc AB, which we established as r theta. So this will be equal to 4 times r theta. So just a little bit of rearranging, we can take away r theta from the right hand side. So we have that 2r equals 3r theta. Perfect, we can cancel out the r's on both sides here. So we have that 2 equals 3 theta. Therefore, that's not very nice. Therefore, the theta equals, dividing over by 3, equals 2/3. Do they want theta? No, they want r. So what we're going to have to do is using this equation that we found before, plug in theta equals 2/3, and then we have it. We're going to be able to find r. So we have that 22 equals r squared multiplied by 2/3 times over by 3 divided over by 2. So we have 66 divided by 2. So we have 33 equals r squared. Now, what do they want? They want the exact value of r, exact value. So taking the square root here, we have that r must be equal to the square root of 33. We don't care about the negative version or the negative root because it's a length, it's a distance, isn't it? R centimeters can't be negative. So your final answer will be that r equals the square root of 33. That's it. Okay, so on to question 4. We're told the curve of equation y equals 2 ln 8 minus x meets the line y equals x at a single point x equals alpha. We have to show that alpha is larger than 3 but less than 4. So first thing, what are they saying? There's a root x equals alpha where this line and curve intersect. Okay, so what do we have? Our curve was y equals 2 ln 8 minus x, and our line was y equals x. We're trying to find the x value where they intersect. If we're trying to find where lines and curves intersect, we set them equal to each other. So we have that 2 ln 8 minus x will be equal to x. What we can do here is take away x from the left-hand side. So we have that 2 ln 8 minus x, take away x, will be equal to 0. So what we can do here is if we plug in 3 and 4, and we see there's a change of sign, then the true root must lie in between those x values. Quickly explain that. If we plug in 4, we can see that our line, y equals x, is above our curve. There we go, it's above our curve. Therefore, because our y equals x line would return a larger y value, this 2 ln 8 minus x, take away x, remember x equals y and line y equals x, and our y value for our curve would be 2 ln 8 minus x, okay? So because our line, y equals x, would be above it, this equation here, ignore the 0, this equation here would return a negative value because we'd be taking away a larger value than what the curve, the function of the curve, would give us. I hope that makes sense. But either way, and vice versa, if we plug in an x value less than this, where we see our curve is above our line, y equals x, therefore they won't intersect, and we will get a positive value because the curve will return a larger y value compared to our line y equals x. Don't worry too much. The key thing we have to think about is that we would get a positive value and a negative value, so a change of sign when plugging in x equals 3 and x equals 4. So that's exactly what we have to do. We plug in x equals 3 and we plug in x equals 4. So plugging in x equals 3, we get 2 ln 8 minus 3 is 2 ln 5. Take away 3. This will give us the answer of, I'm going to start this in my calculator. Let me just write out the next one. We have 2 times ln. This would be 8 minus 4, so that's 2 ln 4. Take away 4. So the values this gives us would be, plugging in x equals 3, 0.22. So that's a positive. We hope we get a negative now. And plugging in x equals 4, we get minus 1.23. Therefore, all we have to say is, therefore, change of sign means that alpha must be larger than 3 and less than 4. And that's all you have to do for part A. Okay, so just quickly for part A, I would say a good summary statement would be to say, therefore, we have a change of sign between x equals 3 and x equals 4. Therefore, the root alpha will be larger than 3 and less than 4. You can also say the function is continuous, our function being 2 ln 8 minus x, take away x, but the key bit of information is in the dark blue here, okay? So moving on to part B, we're told, so figure 2 shows a graph of y equals 2 ln 8 minus x and the graph of y equals x. The student uses the iteration formula xn plus 1 equals 2 ln 8 minus xn, where n is a natural number, in an attempt to find an approximation for alpha. Okay, using the graph and starting with x1 equals 4, determine whether or not this iteration formula can be used to find an approximation for alpha, justifying your answer. Okay, so whenever we see these cobweb or staircase diagram, it's going to be cobweb in general if you have a negative gradient, and staircase in general if you have a positive gradient. Okay, so whenever we see these kind of questions, we're always going to go to the curve. So we're going to go to the curve, we're moving vertically, and then we're going to go to the line. Curve line, curve line, curve line. And then going to the line, we move horizontally. So starting with x equals 4, we're going to go vertically to the curve. then we're going to go horizontally to the line, vertically to the curve, horizontally to the line, and so on. So all we have to say is that the cobweb spirals inwards towards our root. So that's exactly what we're going to say. We can say, using our diagram, the cobweb spirals inwards towards our root. So spirals inwards, give me a second, guys, towards root alpha. Root alpha. So what was the question they asked? Can it be used to find an approximation? So we can say therefore, iteration formula. Let's just say iteration formula. You just need to have a summary statement to show that it does work. Iteration formula can be used for approx. Let's just say that for the approx. Is it perfect? I am actually now going to go through in a little bit more detail why it gives you these answers. So let's kind of go through it step by step. We're starting with x1 equals 4. Okay, so we start with x1 equals 4. And we plug this into the equation to learn 8 minus x, because the iteration equation is just the equation of our curve. Okay, so we plug it into that. If we go up then, this returns a y value of 2.77. But we know that this y value that we return will actually become the next x value that we plug in. Okay, so because we have the line y equals x, we can actually know that if we just see where it crosses this line y equals x, this will give us the location of our x value, 2.77. Because we find the y value from the curve, and with that y value, we can use the reference essentially of line y equals x to show where that next x value would be on our graph. So we have 2.77 after plugging in x1 equals 4, so x2 will be equal to 2.77. So now we plug in 2.77 into our curve equation. This will get us the next y value. This kind of explains where we go, curve line, curve line, curve line, okay? So this gives us the next y value, which would be up here on the curve. If you plug this into your calculator, it gives you 3.31. Then we do the same thing again. This y value that we found will be the next x value, okay? So we go to that line, y equals x, and then we have, so this tells us where our x value would be, this 3.31. And we would keep on repeating this process, and because this cobweb spirals inwards towards our root, this is exactly why this iteration formula is appropriate for the approximation of our root for alpha. And that's exactly it. Alright, so question 5, a little bit of differentiation. We're told that y equals 3 sine theta over 2 sine theta plus 2 cos theta. We have to show that dy d theta is equal to, let me just make this in blue, is equal to a over 1 plus sine 2 theta, where a is a rational constant to be found, okay? So quotient rule, we know quotient rule is v times u dash, take away u times v dash, all over v squared, where u is our numerator and v is our denominator. So exactly that, u is our numerator, u will be 3 sine theta. We know that sine differentiates to cos, therefore u dash will be 3 cos theta. Looking at v, which is our denominator, this will be 2 sine theta plus 2 cos theta. Then differentiating this to get v dash, we're going to have to plug all these in. To get v dash, we have 2 cos theta. Once again, sine differentiates to cos. Then we're going to have minus 2 sine theta as cos differentiates to minus sine. From here, we just have to plug it into our quotient rule equation. Okay, so what do we have? It's quite a lot of work in this question, but let's do it. So we have 2 sine theta plus 2 cos theta. That's going to be multiplied by u dash, which is 3 cos theta. It's going to be take away u, which is 3 sine theta, multiplied by v dash, which is 2 cos theta. It's quite a lot here. Minus 2 sine theta. Okay, great. This is going to be all over v squared. So all over 2 sine theta plus 2 cos theta, all squared. Okay, perfect. So from here, there's not actually much else we can do. We can see eventually in our answer, because of the show that we won that sine 2 theta. But right now, there's not much more that we can do. So we're going to have to expand everything out, which is not ideal, but in the exam you can do this very quickly. So we have 6 sine theta cos theta plus 6 cos squared theta. Nothing too tricky there. Take away 6 sine theta cos theta. Okay, so we're already cancelling some stuff out. Then we're going to have minus 3 sine theta times minus 2 sine theta. So that's going to be plus 6 sine squared theta. It's going to be all over. Let's try to draw that a little bit nicer. It's going to be all over 2 sine theta plus 2 cos theta all squared. So that's going to be 4 sine squared theta plus 4 cos squared theta plus, so then 2 sine theta times 2 cos theta. We're going to have 2 of those. So that's going to be 8 sine theta cos theta. Okay, cool. So from here, what can we already spot? Well, we can see that 6 sine theta cos theta. Take away 6 sine theta cos theta. These two will cancel out. What are we left with? Other thing we have to quickly spot. Cos squared theta plus sine squared theta equals 1. Or sine squared theta plus cos squared theta equals 1. Same thing. So we can see we have that on the numerator and the denominator. So we can actually factor out the 6. So we have 6 sine squared theta plus cos squared theta. So that's going to be 6 times 1, which is just 6. Denominator, same idea. We have 4 times sine squared theta plus cos squared theta, just factoring out the 4 from there. That's also going to be 4 times 1, plus we still have that 8 sine theta cos theta. Okay, so from here, what do we know? Sine squared theta plus cos squared theta equals 1. So we're left with 6 over 4 plus 8 sine theta cos theta. But remember, what are we trying to get to? What are we trying to get to? We need sine 2 theta in our answer, okay? So let's quickly remind ourselves of sine 2 theta, like what is the double angle idea or sine? I'm not sure what's happened here, okay? So we have that sine 2 theta is equal to 2 sine theta cos theta. Okay, so this is going to be useful. However, we don't have 2 sine theta cos theta. We have 8 sine theta cos theta. So because we have 8 sine theta cos theta, we're going to have to times both sides by 4. So 4 sine 2 theta will indeed be equal to 8 sine theta cos theta. Okay, so the substitution that we're going to make is that 8 sine theta cos theta equals 4 sine 2 theta. So what are we left with? We still have that 6 on the numerator. So we have that 6 over 4 plus 4 sine 2 theta. Now quickly reminding ourselves of what we're trying to get to. Always be looking at what you'll get to with these show that questions. So we have a over 1 plus sine 2 theta. So we need 1 plus sine 2 theta. We're going to factor out the 4 from the denominator. So that leaves us with 6 over 4, 1 plus sine 2 theta. So we're very close to what we need right now. What we can do is we can bring that 4 up to the numerator. So we can have 6 over 4 on the numerator all over 1 plus sine 2 theta. Okay, in the form they want it. Sometimes you need to do a little bit of manipulation. 6 over 4, that's the same as just simplifying 3 over 2. So that's 3 over 2 plus, over 1 plus sine 2 theta. Therefore, the value of a that we need, that rational constant to be found, is indeed 3 over 2. That's the final answer to question 5. Alright, so question 6, we have a circle question. The circle C has center A with coordinates 7, 5. The line L with equation y equals 2x plus 1 is tangent to C at the point P as shown in figure 3. So just describing what we're seeing. Show that an equation of the line PA, so PA is going to be, there we go, it's going to be the radius. We know the radius is going to be perpendicular to tangent, is 2y plus x equals 17. So we're trying to find the straight line equation. We know our formula for the straight line equation is y minus y1 equals m multiplied by x minus x1. So what do we know? We know the line PA is going to hit, or go through, sorry, the center, which has coordinates at point A of 7, 5. So we already have x1 and y1. We can also find the gradient. Because we know the radius is perpendicular to the tangent, its gradient will be the negative reciprocal of the gradient of the tangent. So we know the tangent equals y equals 2x plus 1. Therefore, our gradient will be the negative reciprocal. So it's going to be minus a half. Because, once again, because it is perpendicular. Okay, so from here we actually have all the pieces of the puzzle. So we have the y minus y1, which is 5, equals m, which is minus a half, multiplied by x minus x1. X1 is 7. All we have to do now is expand on the brackets and do a little bit of rearranging. So we have y minus 5 equals minus a half multiplied by, so minus a half x, sorry, and minus a half times minus 7, that's going to be plus 7 over 2. From here we can add over 5 to the right hand side. So we have y equals minus a half x. Then we have minus 5, so that's minus 10 over 2. So we add 10 over 2, it's going to be plus 17 over 2. From here, we can see what we're trying to get to in the show that question. We have 2y plus x equals 17. So we're going to add over that half x. So we have y plus half x will be equal to 17 over 2. What else do they want? Well, we saw that we had 2y plus x equals 17. Multiply the whole thing through by 2. So we have 2y plus x equals 17. That is part A. So for part B of this question, we have to find an equation for our circle C. So what do we already know? Well, we know it has the center 7, 5. So let's just start with that. We know it has center 7, 5. Center 7, 5. So we already know, as our circle equation, we are going to have x minus 7 squared plus y minus 5 squared will be equal to, as our circle equations are, will be equal to the radius squared. Now, we currently don't have the radius, but we can find the radius. So what do we know? We know that P to A will indeed be our radius. We know that A has coordinates 7, 5. Just make sure that's correct. Has coordinates 7, 5. But we can also find the coordinates of P. How can we find the coordinates of P? Once again, they like you to use your answer to part A in these kind of questions. Well, we know the tangent equation is y equals 2x plus 1. But we also know the equation of the line PA that goes through. So there we are. Equation of the line PA is 2y plus x equals 17. Okay? To find the coordinates of P, this will be where these two lines intersect. So we can simply find where these two lines intersect. So just going through it neatly here. We have that y equals 2x plus 1. And we have that 2y plus x equals 17. We can make in the substitution that y equals 2x plus 1. So we have 2 times 2x plus 1 plus x equals 17. Perfect. So from here, just expand out the brackets. 2 times 2x, we have 4x plus 2 plus x equals 17. So 4x plus x, we have 5x. Take away 2 from the right-hand side, equals 15. So we have that x equals 15 over 5, which is 3. To find the corresponding y coordinate at P, we can just use the equation y equals 2x plus 1. So we have y equals 2 times 3 plus 1. So that is 6 plus 1, that is 7. So y equals 7. This is great. We now have P to be 3, 7. We have A to be 7, 5. So what we can do is we can actually find the distance between these 2 points to find the radius. From here, we can actually construct a triangle and use Pythagoras. So we are trying to find the distance of our vector AP, but an easy way to think of this is just draw a triangle. So what is the change in x? We have P up here, we have A down here. What is your change in x? Well, we have to get from x equals 3 to x equals 7, or 7 to 3, however you want to think of it. So the change in x, a bit wobbly, equals 4. And change in y, getting from 7 to 5, will be 2. We are interested in the direct distance from P to A, the hypotenuse. Use a bit of Pythagoras. So we just do 2 squared plus 4 squared will be equal to c squared, the hypotenuse squared. So we have 4 plus 16 equals c squared, or in other words, the radius squared. So this will be 20 equals c squared. So our radius actually, r will be equal to root 20. However, as we know in our circle equation, we do write, as highlighted before, we write the radius squared. So our full circle equation will be x minus 7 squared, because we have that center of 7, 5, so we have y minus 5 squared, will be equal to our radius squared. Our radius is root 20, so our radius squared will be 20. And there is your equation for our circle C. Okay, so part C of this question, we're told the line of equation y equals 2x plus k, where k does not equal 1, so it's not a current tangent to C at point P, is also tangent to C. Find the value of the constant k. So first things first, let's just try draw on what we're thinking here. We know it's going to be tangent, so it's going to intersect that circle at one point, okay? It has the same gradient, so we know the gradient is going to be the same, but we also know it will just touch the circle because it's going to be tangent. Therefore, more or less, that line will have to be going through here. Now, there's 2 different ways you could do this. I know when you think tangent only intersecting once, a lot of people immediately go to the discriminant. That is the longer way to do this question. The other way you can do this question is I would call it maybe like a stepping method is the way I'll describe it. What we can see is because we know to get from P to A, and then to get from A to, let's call it J, get from A to J, we're going to have to go the same change in X and the same change in Y as we did from P to A. Therefore, we know that P, going all the way back to before, we know that P is, trying to find it, 3, 7. So we had 3, 7. Then we had 7, 5 for our center A. So what was the change in X? The change in X was 4 plus 4. So to get this new point, we called it J, we're going to have to add another 4. So it's going to be 11. And we're also going to have what happened to our y's. 7 went to 5, so that's minus 2. So we're going to take away another 2. So our point that this tangent will go through, which is on our circle, will be 11, 3. We called it point J, but it's just a point on the circle, which is our tangent, which has the equation y equals 2x plus k goes through, okay? So what we have to do now to find k is plug in x equals 11 and y equals 3. So we have that 3 equals 2 times 11 is 22 plus k. Therefore, our value of k will be equal to 3 minus 22 is minus 19. And that's a very quick way to do this. The long way to do this would be to use a discriminant. Now what you could do, so we currently have the equation y equals 2x plus k. So this is going to take me a second, but I want to be very clear. If you do this in the exam, you would still get the right answer. So we have, there we go, we have that y equals 2x plus k. We also have our circle equation to be x minus 7 squared. It's going to be quite long, plus y minus 3 minus 5 squared. So feel free to skip through this if you are not interested in this longer way, equals 20, okay? So we know it's tangent to a circle, therefore b squared minus 4ac will be equal to 0 once we sub in a y equals 2x plus k into our circle equation. So let's do it. We have x minus 7 squared plus, so then instead of y, we're going to have 2x plus k. So plus 2x plus k minus 5 squared. So we're going to treat this k minus 5 as one constant value just to make our lives a little bit easier, equals 20. So let's expand out that x minus 7 squared. So we have x squared minus 14x plus 49. Amazing. Then we have plus 2x plus k minus 5 squared. Okay, it's going to be a little bit trickier to write this out. So it's going to be plus 4x squared plus 2 x times k plus 5, so that's going to be 2k minus 10. We're going to have two of those. So it's going to be, 4k minus 20. So we're going to have 4k minus 20 x, and then we have plus k minus 5 squared, and that would be equal to 20. So now we have to collect like terms here. So this is a lot longer, guys. If you could spot the other way, do the other way. Then we have minus 14x plus 4k minus 20x. Okay, so that will be plus 4k. Then we have minus 14 minus 20, so it's going to be minus 34x. Then we have plus 49 plus k minus 5 squared. Oh, we have to take away the 20 because we have that 20 on the right hand side. So we're going to have plus 29 plus k minus 5 all squared. So k minus 5 all squared, that's k squared minus 10k plus 25. So let's rewrite everything with the correct constant. So we have 5x squared plus 4k minus, so there should be brackets around that, plus 4k minus 34x. So plus 29 plus 25, so it's going to be plus 54. Actually, we should probably write that at the end to make it look a little bit better. So we're going to do plus. So guys, this is very long. You have to be very careful. Very easy to make silly mistakes in these kind of questions. So I would be very careful if you go about this, doing it this way. So then, because it's tangent, we know that b squared minus 4ac will be equal to 0. Why? Because we have one root, because it's tangent, one intersection. Okay, so continuing on from here, guys, b squared minus 4ac. So we have b squared, so it's going to be 4k minus 34 squared. Going to have to put out the calculator for this one. Minus 4 times a, so a is 5, so it's going to be minus 20 multiplied by c, so that's going to be k squared minus 10k, because this is all a constant, guys, all a constant, plus 54, and this will be equal to 0. Okay, so 4k squared, we can do that one in our heads, that's 16k squared. We have minus 34 times 4, we're going to have two of those, so minus 34 times 4, answer times 2. So we have minus 272k. 34 squared is 11 plus 1156. Take away 20k squared. Then we have minus 20, so that's plus 200k, I believe. Yeah, and then we have minus 20 times by 54. So minus 20 times 54 is going to give us 1000 or minus 1080. That'll be equal to 0. So now we can clean this up a little bit. 16k squared minus 20k squared, so we have minus 4k squared minus 72k, and then we have 1156, take away 1080, so 1156, take away 1080 will give us 76. Okay, so that's plus 76 equals 0. Now, if you put this into your calculator to solve for k, just put it into your equation, polynomial, solving a polynomial. So we have minus 4, minus 72, plus 76. We get two values for k. We get that k equals 1, but we know that in the question, if it lets me, okay, in the question, they told us, let me zoom out a little bit here, that k cannot be equal to 1, because that's that's the tangent equation that we originally had. And then the other answer is indeed, I'm going to show here, it is minus 19. So we do indeed get k equals minus 19, doing the discriminant way. So this would be fine in the exam if you're panicking, or if it's in a longer question. For this specific one, it would work, but with circle questions, drawing the diagram can be faster, as shown here. But you do get the right answer eventually. Okay, so question 7, a little bit of integration. Given that k is a positive integer, show that the definite integral upper limit 3k, lower limit k of 2 over 3x minus k, integrating with respect to x, is independent of k. So let's just do the integral and show that the answer has no k's in it. That's what they mean when it's independent of k. So here we go. So, glitching out a little bit. Okay, let's go. So we have the definite integral, upper limit 3k, lower limit k of 2 over 3x minus k. Now the key thing to spot in this kind of question is that the numerator looks like our denominator differentiated. Because we know if we have f dash x over f of x, so some function of x, and it differentiated in the numerator, if we were to integrate this, this would be equal to the natural log of the function of x in our denominator. Now it kind of looks like that. We can see that our denominator, 3x minus k differentiated, would be 3. We have 2, so this is similar. So what we can do is we can actually use a little bit of reverse chain rule. So we have a guess here. Our guess will be the natural log of 3x minus k to be the integral, okay? So what we're going to do, we're going to differentiate this and then compare, okay? So differentiating this would give us 3 over 3x minus k. Now, this is quite similar to what we currently have, but we have 2 at the top. So we're going to have to multiply this by 2/3 if we just wanted to have 2. 3 multiplied by 2/3 is simply 2. So what we're going to have to do is multiply each side. So our guess and the actual answer by 2/3 in order to get that 2 over 3x minus k. So what are we left with? Well, our integral will be 2/3 multiplied by the natural log of 3x minus k. And then we have to plug in our limits still, and our limits are indeed 3k and k. So plugging in 3k, we have 2/3 multiplied the natural log, so 3 times 3k, that's going to be 9k minus k, which is going to be 8k, but we'll leave that for now. Actually, it does tell us that k is a positive integer, so we don't need to put the modulus there. And then we have, plugging in k, we have 2/3 times the natural log of 3 times k minus k, so it's going to be ln, we already did that, ln of 3k minus k. So nothing scary there. Simplifying this out, we can take out those 2/3, and then we have ln of 8k, take away the natural log of 2k. And we know that when we have ln a, take away ln b, we can write this as ln a over b. So what we can do is we have 2/3 multiplied by the natural log of 8k over 2k, and we can quickly see that our k's would cancel out, and 8 divided by 2 is just 4. So we're left with 2/3 times the natural log of 4, which we can see is independent. I'm going to write independent, there we go, of k. So it doesn't matter what k would be because it would always give us the answer of 2/3 ln 4. Okay, so looking at part B, we have to show that the integral, definite integral once again, upper limit 2k, lower limit k, of 2 over 2x minus k squared dx, integrating with respect to x, naturally, is inversely proportional to k. Inversely proportional to k, all this means is we're going to have something on the numerator over k. That's what it means. So our answer wants to be something with k in the denominator, okay? So looking exactly like this. So let's integrate it. So we have the definite integral, 2k upper limits, k lower limits. I believe, just reminding myself, 2 over 2x minus k squared. So we have 2 over 2x minus k squared. However, we know when we're integrating, we're going to rewrite that 2x minus k squared as 2x minus k to the power of minus 2. So here we can do some simple integration as we normally would by raising that power up. This is a reverse chain rule here. All we have to do, raise that power up by 1, divide by the new power, and divide by inside of the bracket differentiated. So what do we have? Raising that power up by 1, we have 2x minus k to the power of minus 1. We're going to divide by the new power, so it's going to be 2 divided by minus 1, and we also have to divide by inside of the bracket differentiated. So inside the bracket differentiated would just give us 2. So we also have to divide by 2. So this is going to be 2 over minus 2, so we're going to be left with minus 1. Let me just write this clearly. Minus 1 over, because 2x minus k to the power of minus 1 is the same as writing 1 over 2x minus k. 2x minus k. And then from here, we just have to plug in our limits of 2k and k. Remember, we're trying to show that it's inversely proportional to k, so let's see how this goes. So plugging in 2k, we have minus 1 over, so 2 times 2k, that's going to be 4k minus k, which is just 3k. But let's go step by step. So that's minus 1 over 2 times k is 2k, so that's going to be 2k minus k. From here, further making it look a little bit nicer, we have 1 over 4k minus k, which is minus 1 over 3k, minus minus, so it's going to be plus 1 over 2k minus k, is just plus 1 over k. So we have minus 1 over 3k, where we are adding or subtracting fractions, they have to have the same denominator, so we're going to have to multiply top and bottom here by 3. So it's going to be plus 3 over 3k, which leaves us with 2 over 3k. Another way you could write this is 2/3 over k, either way. Therefore, because we have that k in the denominator, we're going to be inversely proportional to k. And that is your answer for, I believe, we are on question 7. Yeah. Okay, question 8, we have a little bit of trigonometric modelling. So we're talking depth of water, d meters, so it's in meters, in a harbour on a particular day is modelled by the formula d equals 5 plus 2 sine 30t, where t must be larger than or equal to 0 and less than 24, where t is the number of hours after midnight. Very, very important. So t is the number of hours after midnight. Okay, a boat enters the harbour at 6:30 a.m. So 6:30 a.m., that's going to be t equals 6.5, because that's 6.5 hours after midnight. And it takes 2 hours to load its cargo. So 2 hours, that's going to be 8:30 a.m., so t would be 8.5. So we are done at 8:30 loading the cargo. The boat requires a depth of water to be at least 3.8 meters, so we need at least 3.8 meters before we can leave the harbour. Okay, so we have some key information. Highlight it if you want. Find the depth of water in the harbour when the boat enters the harbour. Okay, so we enter the harbour at t equals 6.5. So this is pretty simple. All we have to do is we have that d equals 5 plus 2 sine 30t. Remember, we are in degrees, guys. Remember, we are in degrees. Make sure you're in degrees. Pay very close attention because this can lose you quite a few marks in your exam if you don't spot the degrees or radians. Radians in calculus, always in radians. In this case, they've specified degrees. So be careful with that. So 30t, t, when we enter the harbour, will be 6.5. So it's going to be 30 times 6.5. So you just plug it into your calculator. We do 30 times 6.5. So making sure we're in degrees. Then we do sine of our answer. Then we do answer times 2. Then we do answer plus 5. So our depth would be to 3 significant figures with the dB 4.48 meters. Once again, we know we're in meters. So moving on to part B, we have to find to the nearest minute the earliest time the boat can leave the harbour. So when can it leave the harbour? Well, we know the depth must be 3.8 meters. So 3.8 will be equal to 5 plus 2 sine of 30t. Okay, so this needs to be the case. Now we have to find the times, the t values, when our depth, or d, equals 3.8. But remember, key bit of information, we know that it takes 2 hours to load its cargo after 6:30 a.m. So t must be at least 8.5. Anytime before 8:30 or 8.5 hours after midnight, we won't have loaded our cargo yet. So we have to consider multiple solutions, most likely, otherwise they wouldn't have given us this information. So from here, it'll be 3.8 take away 5, put it in your calculator, we get minus 1.2, divide over by 2, so we have minus 1.2 over 2 equals sine of 30t. From here, we can then find the inverse of sine of minus 1.2 over 2, and then we're going to have to find multiple solutions, okay? So remember, our primary value, we can simply just do the inverse sine of minus 1.2 over 2. So minus 1.2 over 2, inverse sine of that will give us, in degrees, 36 point, so it's even minus 36, minus 36.87 we'll call it. And once again, we know if we were to divide this by 30, we would get a negative time anyway, and also it would be so small that it wouldn't even matter. So we know this is not going to be the correct value. This is our primary value, we can call it P1. Our secondary value for sine will be 180, take away our primary value. So this will give us 216.87. So this could be a viable value for t. If we were to divide this by 30, because remember, these are the solutions to 30t. So dividing by 30, we don't even have to consider this 36 or minus 36.87, but we can consider 216.87. So if we do 216.87 divided by 30 to get our t, this would give us 7.23. So 7.23, but we know, looking back up, that t needs to be 8.5 or greater for our boat to have loaded its cargo. So this cannot be the case, as t must be larger than, or we can write t is less than 8.5, so this will not work. So to find the next value, we would get our minus 36.87. Let me just find the inverse sine of minus 1, but you can store your answer if you want to make it a little bit faster. So then we're going to add 360, so we're going to do our primary value, P1, plus 360, get the next solution. If in doubt, remember our sine graph repeats every 360 degrees if you want to draw it out. But you should just know this by the time of the exam. So you do your primary value plus 360, and this gets us 323.13. We want to divide this by 30 to get our value for t, because remember 323.13 is our value for 30t. So dividing it by 30 gets us 10.771. We'll leave it like that, 10.771. But looking back up to the question, they want us to find the time to the nearest minute. So they don't want the number of hours after midnight. They want the time to the nearest minute. So we know we're going to have 10 something a.m. And then we have, taking away 10 from 10.771, we would get that 0.771. So we do 0.771 multiplied by 60 to get it into minutes. And this will give us 46.26 minutes. They want it to the nearest minutes. So we're going to round down there. It's going to be 10:46 a.m. to be the earliest possible time when the depth is 3.8 meters and the cargo had been fully loaded. That is question 8. Okay, question 9, here we go. Figure 4 shows a sketch of the curve of equation x squared minus 2xy plus 3y squared equals 50. Okay, we have to show that dy dx equals y minus x over 3y minus x. A little bit of implicit differentiation. Let's just rewrite our equation very quickly. So we have that our equation to be x squared minus 2xy. I'm going to have to differentiate this implicitly. Remember, when we're doing implicit differentiation, whenever we differentiate a function of y, we have to multiply it by dy dx. So what do we have? Let's just differentiate it. So we have 2x So here we have the minus 2xy. We're going to use a little bit of product rule here. Remember, we're going to leave, differentiate, differentiate, leave. So we can call this minus 2x as our first term essentially, and that y as our second term. Okay, so leaving, then differentiating. So we have minus 2x multiplied by y differentiate, it's just dy dx. And then we're going to have differentiate leave. So it's going to be minus 2 times y, then we leave the y. So it's going to be minus 2y. And then differentiating 3y squared, that's just going to be 6y. But because it's a function of y, we multiply it by dy dx. And this will be equal to 0. Because 50, our constant, will disappear when differentiating. Great. So now we need to make dy dx the subject of the formula because we have dy dx equals y minus x over 3y minus x. Okay. So we want all of those dy dx's on one side. So we're going to have 2x minus 2y equal to 2x dy dx. Take away 6y dy dx. Perfect. Factor out dy dx from that right hand side. So we have 2x minus 2y equals dy dx 2x minus 6y. Okay. So then all we have to do now, divide the left hand side by 2x minus 6y. Nothing too tricky there. So dividing over, we have 2x minus 2y over, it's not very good, over, there we go, 2x minus 6y equals dy dx. Perfect. Looking good so far. Now we can divide everything through by 2, because we can see we have y minus x and 3y minus x, so it makes sense to divide everything through by 2. Minus y over x minus y to be equal to dy dx. Now, because this is a show that question, we have to get it exactly in the form they want. They have y minus x and 3y minus x. So what we have to do, remember, if we do something to the top of the fraction and the bottom of the fraction, this doesn't change the fraction. So we can multiply the top and the bottom by minus 1. Multiplying the top and the bottom by minus 1 gets us exactly what we need. We have y minus x over 3y minus x to be equal to dy dx as required. And that is part A. Right, so part B of this question, we're told the curve is used to model the shape of a cycle track with both x and y measured in kilometers. The points P and Q, so P and Q, represent points that are furthest west and furthest east of the origin, O, as shown in figure 4. Using part A, so using this dy dx, find the exact coordinates of point P. So what do we know? We know that when we have a horizontal line, our dy dx will be equal to 0. But we can see at point P, we have this vertical tangent. If we have a vertical tangent, this means our gradient is infinite. We have infinite change of y for no change in x. Therefore, our dy dx must be undefined. To be undefined, we have the fraction y minus x over 3y minus x. For the fraction to be undefined, the denominator, as we know, must be equal to 0. Because we know if we're dividing by 0, it's undefined. So what do we have for part B? We have that 3y minus x must be equal to 0. So we have that 3y equals x at the point P, okay? In order to have this vertical tangent, this dy dx being equal to infinity or dy dx being undefined, okay? So from here, what do we do? Because we know that 3y must be equal to x, we can now plug it in into the equation of our curve to find the solution for either x or y, okay? So we have x squared minus 2xy, quickly rewriting it down here. We have x squared minus 2xy, and what did we have? Sorry guys, plus 3y squared equals 50, okay. Plus 3y squared equals 50. So from here, we can make a substitution of x equals 3y. So we have 3y all squared minus 2 times 3y times y plus 3y squared equals 50. So from here, we have 9y squared minus 2 times 3, so that's going to be minus 6y squared plus 3y squared will be equal to 50. So 9 minus 6 plus 3, that's just going to be 6y squared equals to 50. So we have that y squared will be equal to 50 over 6. Therefore, y will be equal to, put it in your calculator, find 50 over 6. So 50 over 6, take the square root. This gets you 5 root 3 over 3. So it's going to be plus minus 5 root 3 over 3. Now here's a question. Do we care about the positive or the negative y coordinate? Let's go up. Let's just look where P is. We can see that we have a negative y value at P and we also have a negative x value. So we care about negative y's and negative x's. So we have that y must be equal to minus 5 root 3 over 3. So we have that y equals minus 5 root 3 over 3. From here we can find x. Now we know that x equals 3 times y. So we can quickly see that timesing our y value by 3, this will just give us x equals minus 5 root 3. So the coordinates of our point P would be minus 5 root 3 as our x coordinate, and our y coordinate will be minus 5 root 3 over 3. Okay. Now moving on to part C. Part C, what do they want? Explain briefly how you would find the coordinates of the point that is furthest north of the origin O. So furthest north, okay, in this case, we would indeed have dy dx, that's not very straight, we would have dy dx equals 0. Okay, so this is good. Therefore, the numerator would be equal to 0. So y minus x equals 0. So we just have to explain it, we don't have to go through the whole thing. So we would have y minus x equals 0, so we take that y equals x, we would plug into curve equation. Same idea as before, exact same thing, they just want you to describe how you would do it. Plug into the curve equation, solve for y or x, so solve for, doesn't matter which one you say, solve for y slash x, and then from there, we have to make sure, same thing as before, because dy dx equals 0 at 2 points. You can either have this furthest north point, or you could have this furthest south point. So we have to say, we make sure we take the positive y and the positive x value. Just exactly what we say, solve for y for x, and take the positive y and x values. And that's exactly it. Nothing too tricky. It's the same idea as part B, but in this case, we just have to explain it. That's why we are only getting 1 mark for this question. But yeah, nothing too tricky. On to question 10, I believe. Okay, question 10, differential equations. The height above the ground, h meters, of a passenger on a roller coaster can be modeled by the differential equation dh dt equals h cos 0.25t over 40, where t is the time in seconds could be important later on, from the start of the ride. Given that the passenger is 5 meters above the ground at the start of the ride, so start of the ride t equals 0, h equals 5, already useful piece of information to find that constant of integration. We know we're going to have to use that. Show that h equals 5 times e to the 0.1 sine 0.25t. So we're going to have to solve this differential equation. What do we know when solving differential equations? All of our h's must be on one side, all of our t's must be on the other in this case. So we're going to divide over by h. So we have 1 over h dh equals, then multiply over by dt. So we have cos 0.25t over 40, and we're integrating with respect to c. So we multiply over by dt. All we have to do now, integrate both sides. So you have to know by the time of the exam, integrating 1 over h is going to be the natural log of h. And this will be equal to integrating cos of 0.25t. This is simply going to be, so the integral of cos is sine. So we have sine 0.25t, but remember we're going to have to divide by inside of the bracket differentiated, so we're dividing by 0.25. Dividing by 0.25 is the same as timesing by 4. So we're left with 4 over 40 sine 0.25t plus c. So 4 over 40 is just 1 over 10. So you can rewrite this as sine 0.25t over 10 plus that constant of integration. Remember, we would have constants of integration on both sides because we have indefinite integrals, but we can combine this into one constant of integration on this right-hand side. So from here, what do we know? We know that when t equals 0, h equals 5. So we're going to use this to find that plus c, to find that constant of integration. So from here, t equals 0, so we have sine of 0.25 times 0. This is just going to be sine of 0, and we need to know, you can do it with a sine graph, or do a calculator, or just know it, sine of 0 is just 0, okay? So everything here, all of this here, will be equal to 0. So we have the natural log of 5 will be equal to c. So we know that constant of integration is ln 5. Let's write it all out once again. So we have that ln h equals sine of 0.25t, 0.25t over 10 plus ln 5, okay? So from here, what do we know? Well, we're going to want to eventually get an e in our answer, because we have h equals 5 times e to the power of 0.1 sine 0.25t. So what we're going to do, we can also see we actually have 0.1. So actually, before we even carry on, I'm going to rewrite this as, instead of over 10, as 0.1 sine of 0.25t plus ln 5. What we can do is, because we're going to want to take e of the whole thing, and we're going to want to get rid of that natural log, let's take away ln 5 from our ln h. Remember, if we have ln a, take away ln b, this will be equal to ln a over b. So taking away the natural log of 5 from the natural log of h, this is going to be ln h over 5. And this will be equal to 0.1 sine of 0.25t. Okay, that's great. From here, we can e both sides to get rid of this natural log. So we have h over 5 to be equal to e to the power of 0.1 sine of 0.25t. Great, almost there. What to do now? Make h the subject of a formula. You can see we're actually almost there. We just have to multiply over by 5. So last step, h equals 5 times e to 0.1 sine of 0.25t. Okay, now as they like to do with these differential equations, we're going to see in part B, the fact that sine is bounded by -1 and 1, or cos could also be the case, is very important. So what do they ask us in part B? State the maximum height of the passenger above the ground, the maximum height, okay? So here's the thing we have to know. Sine of anything, but in this case sine of 0.25t, must be less than or equal to 1, or larger than or equal to -1. So the maximum value we can take is 1, minimum value is -1. So our height will be 5 times e to the 0.1 times by sine of 0.225t, but here's what we know. We know the maximum value that sine of 0.25t can take is 1. So this will be e to the power of 0.1 times 1. The reason we want the most positive value for e to the power of something is because if we draw out our e to the x graph, we can see, apologies, we can see the more positive x value we put in, it's not ideal, but the more positive x value we put in, the more positive y value we get. So to get the maximum possible height, we're going to want e to the power of the most positive number. So this is going to be using that maximum possible value of sine to be 1, okay? Sometimes they may want you to take the minimum possible value if you're taking something away, for example. But in this case, we care about when sine of whatever equals 1. So we have our height to be 5 times e to the 0.1, because 0.1 times 1 is just 0.1. So plug it in the calculator, 5 times e to the power of 0.1 would just be 5 points. They want it 3 significant figures that they specify. If not, we're going to go, okay, we're going to go 3 significant figures. So we can have the height to be 5.53 meters. 5.53 meters. Just checking once again, yep, the height is indeed in meters. Make sure you're in the correct units when doing these questions. Now looking at part C, I assume normally they want us to find the t value when that sine of 0.25t will be equal to 1, but let's see if that's the case here. The passenger reaches a maximum height for the second time, guys, t seconds after the start of the ride. Find the value of t. Okay, this is interesting. So what do we care about? For the maximum height, we care about when sine of 0.25t is equal to 1. However, we care about the second time, so we're going to have to find multiple solutions to this. So we have 0.25t to be equal to the inverse sine of 1. So our primary value, just taking the inverse sine of 1, this is calculus. Why is it calculus? Because we're in differential equations. Sorry, why is it radians? Sorry, because we're using differential equations in calculus, we're always going to be in radians. So previously we did have a degree question. Make sure you're back in radians. Taking the inverse sine of 1, you could just know this, it is just pi over 2. So we have that 0.25t to be equal to pi over 2. But we also have it, we can do 180 minus our answer, or in this case, pi minus our answer would also be pi over 2. So that doesn't help us. So then we would add 360 or 2 pi. So this gives us 5 pi over 2 as our other or secondary value, because we care about the secondary value because we want the second time it reaches the maximum height. Because if we were to do the first time, we would do pi over 2 divided by 0.25, same as timesing by 4. So we get t equals 2 pi, but that would be the first time we reach the maximum height. So we don't care about this. We care about t equals 5 over 2 times 4. So you can put it in the calculator if you want, it will just be 10. So t equals 10 pi for the second time we reach the max height, okay? They tried to get you with these little details, second time, max height, not the first time. But either way, it's the same idea. So then we just do 10 times pi. Remember, this is in seconds. This will be 31.3 significant figures, so 31.4 seconds. I believe they want it in seconds. Let's check if they want it in minutes or something. T seconds after the start of the ride. Find the value of t. Value of t would indeed be 31.4 seconds. And that's it. That is question 10, I believe. Yeah. Okay, question 11, a little bit of binomial expansion, a bit of an annoying one. We have to use binomial expansions to show that the square root of 1 plus 4x over 1 minus x is approximately 1 plus 5 over 2x minus 5 over 8x squared. So first things first, we can't be having it in this form. We're going to have to rewrite it. So we currently have, get my pen up, we currently have 1 plus 4x over 1 minus x. We can split this up as 1, zoom in a little bit, 1 plus 4x to the power of a half, because we can split up the square root, so we have just the numerator square rooted. Quickly drawing that out here. We can split this up using our rules of surds as the square root of 1 plus 4x over the square root of 1 minus x. We can rewrite this because we want it to the power of something, each thing to the power of something. So we have 1 plus 4x to the power of a half, taking the square root is the same as the power of a half, multiplied by 1 minus x to the power of minus a half. So half, once again, because it's square rooted, minus a half, because we're getting it from the denominator to the numerator, because we're going to want to multiply our binomial approximations of each in order to get this final approximation of 1 plus 5 over 2x minus 5 over 8x squared. So what do we know? We know that when we have 1 plus ax to the power of n, and we want to use the binomial approximation, this will be approximately equal to 1 plus n times ax, where a is just some constant, plus n times n minus 1 over 2 factorial. This is in the formula sheet, I believe. Ax squared. Okay, so this is in the formula sheet. We're just going to have to plug in n being the power, so it'll be half and minus half, and ax being 4x and minus x for each bracket. So let's go one by one. Let's first start off with 1 plus 4x to the power of a half. So we have 1 plus, so we have half times 4x, that's just going to be 1 plus 2x. Then we're going to have plus n times n minus 1, so it's going to be half multiplied by minus a half. And then we have, that's going to be over 2 factorial, or just over 2, same thing. 2 factorial is just 2, multiplied by ax squared, so multiplied by 4x all squared. 4x all squared, we can actually just write that in now, is going to be 16. 4 squared is 16. 16x squared. So what do we have? We have a half times minus a half divided by 2, that's minus 1 over 8. Minus 1 over 8 times 16, so minus 16 over 8 is just 2. So it actually leaves us with 1 plus 2x minus 2 x squared. Okay, cool. So let's move on to the next bracket, which was 1 minus x to the power of minus a half. So we have 1 minus x to the power of minus a half. Same idea as before. So we're going to have 1 plus, this is going to be n times ax. So we have minus a half multiplied by minus x. And then we're going to be adding on n times n minus 1. So it's going to be minus a half multiplied by minus 3 over 2, taking away 1, over 2 factorial. And we have minus x all squared. Okay, so let's sort that out. We have 1 plus minus a half x times by minus x. Minus times a minus is a positive, so that's minus, or sorry, plus x over 2. Plus, so we have minus a half times minus 3 over 2 over 2. Put it in your calculator. We can actually see that's going to be plus 3 over 4 divided by 2. So it's going to be positive 3 over 8 x squared. The reason it's positive x squared is because that minus x is all squared. So there we have it. So we have this 1 plus x over 2 plus 3 over 8x squared. And then we also have from before that 1 plus 2x minus 2x squared. Now remember, what do we want in our approximation? We only want up to the x squared term. So when multiplying these two by each other, we have to be pretty careful to only get up to x squared. So what we're going to do is we're going to do 1 times the bracket on the left. So 1 times the bracket on the left, we're going to have 1 plus, let's write this as a half x, 1 plus a half x plus 3 over 8 x squared. Now we're going to do 2x times by 1. So we're going to have 2x plus 2x times by x over 2 is going to be x squared. So it's going to be plus x squared. And then we're going to do minus 2x squared only times by the 1. Remember, the reason why we're only doing it like this is so we don't get any order of x, or x to the power of 3, x to the power of 4, and so on. If you want, you can try it yourself. You can see it. We would only be getting up to the x squared term, so we can't be doing anything more than this. So we do minus 2x squared times by 1, so that'll be minus 2x squared. Now all we have to do is add these all together. So what do we get? 1 plus 0 and 0, it's just going to be 1. Half x plus 2x is going to be 5 over 2x. And then we have minus 2x squared plus x squared, so that's minus x squared, plus 3 over 8x squared. So it's going to be minus 5 over 8 x squared. And is that what we wanted in our answer? Let's check it. 1 plus 5 over 2x minus 5 over 8x squared. Yep, that's exactly what we needed for part A. Now let's go to part B. Okay, so looking at part B, we're told a student substitutes x equals a half into both sides of the approximation shown in part A in an attempt to find an approximation to root 6. Give a reason why the student should not use x equals a half. Okay, so what do we know? When we have 1 plus ax to the power of n and we want to use a binomial approximation, we must have that what is going on? We must have that the modulus of ax must be less than 1. Okay, so if we focus on the numerator here, looking at this 1 plus 4x, so we expand it out, 1 plus 4x to the power of a half. For this to be valid, we must have ax, so 4x, the modulus of 4x must be less than 1. We can rewrite this as 4x must be larger than minus 1, less than 1, because the modulus is the positive version, right? So because we're taking the positive, the modulus of 4x, this means just 4x must be larger than minus 1 and less than 1. So then we can just divide over by 4. So we have that x must be larger than minus a quarter and less than a quarter. But we can see x equals a half is not valid. It does not satisfy that x must be less than a quarter. So all we have to say is x equals a half is not valid. Let's move on to part C. We're going to have a little bit of calculator work here. Let's see. So substitute x equals 1 over 11 into the square root of 1 plus 4x over 1 minus x. equal 1 plus 5 over 2x minus 5 over 8x squared to obtain an approximation to root 6. Give our answer as a fraction in its simplest form. Okay, so let's quickly just rewrite what we have in the question. We have 1 plus 4x over 1 minus x equal to 1 plus 5 over 2x. Take away 5 over 8x squared. Let me just make sure that is the approximation, everything's correct there. Okay, perfect. So all we have to do is sub in x equals 1 over 11. So we have x equals 1 over 11. Let's sub it into both sides and just see what happens, see what we get. Normally, what we have on the left-hand side will be something like root 6, and then we're going to have to manipulate our answer on the right-hand side in order to get an actual approximation for root 6. So let's just sub it in. So we have the square root of 1 plus 4 times 1 over 11. So, okay, 1 plus 4 times 11. So we have 1 plus 4 over 11. That's 15 over 11. So we have 15 over 11 on the numerator. The denominator, we have 1 minus 1 over 11. So that's just going to be 10 over 11. That's going to leave us actually with 15 over 10 because these 11s both in the denominator. We can multiply the top and the bottom of the fraction by 11 without changing it. So that actually leaves us with the square root of 15 over 10. 15 over 10 is the same as 3 over 2. So what do we currently have? We have the square root of 3 over 2. We can split this up actually once again to have root 3 over root 2. Now subbing in x equals 1 over 11 into the right hand side, we have 1 plus 5 over 2 multiplied by 1 over 11. Be very careful when you put this in your calculator, guys. You don't want to make any silly mistakes. I would also recommend putting it in your calculator. I'm going to be taking away 5 over 8 multiplied by 1 over 11 squares. That's just 1 over 121. Make sure you're careful when doing this once again, guys. But this would give you, be very careful, 1183 over 968. Okay. But that's the answer to root 3 over root 2. So we want to get root 6, or we want to see root 6 on the left-hand side. So first thing I'm thinking, if we multiply the top and the bottom by root 2, we'll rationalize the denominator and we'll get root 6 in the numerator. Sounds pretty perfect. So multiplying the top and the bottom by root 2, we get root 3 times root 2 is just root 6. So we get root 6 over 2 equal to 1183, same thing as before, 1183 over 968. Remember, because we're doing the same thing to the top and the bottom of the fraction, it does not change the fraction. So all we have to do to get an approximation of root 6, just multiply the right-hand side by 2. So multiplying the right-hand side by 2 will indeed get us root 6 to be 1183 over 484, just putting in a calculator. And because that was the binomial approximation that we did up to x squared, that is indeed your final answer. As a fraction, to get 1183 over 484 as your approximation to root 6 by manipulating that left-hand side to make it look like root 6, and then doing that final rearranging, multiplying by 2. And that is our fraction as a simplest form. That's how the calculator gives it to us. So that's your answer to question 11. That's it. Okay, question 12, a little bit more modelling. We're told the value, V pounds, of a vintage car T years after it was first valued on the 1st of January 2001, seems quite key information, is modelled by the equation, so that's T years, sorry, modelled by the equation V equals A times P to the power of T, where A and P are constants. Given the value of the car was 32,000 on the 1st of January 2005. So 1st of January 2005, our T will be, so it's T years after 2001. So, if in doubt, in the example, that adrenaline, all those nerves, 2002, 2003, 2004, 2005, 4 years after. So we have T equals 4, just in case you're worried about that. So then from here, £50,000 on the 1st of January 2012. So here we have T equals 11. Okay. We have to find P to 4 decimal places, and we have to show that A is approximately 24,800. Okay, cool. So what we have to do, let's just write out down what we know. So we know that V equals, we have that V equals A times P to the power of T. Great, so let's put 32,000 as the value. 32,000 equals A times P, and then we had that T was equal to 4, and it was 50,000, the value to be equal to A times P to the 11. Let's label this equation 2, this equation 1. Then from here, what we can do, divide one equation by the other. So let's do equation 2 divided by 1. Why are we doing this? Well, we have two unknowns currently, A and P. We only want one unknown. We can see if we divide one equation by the other, we can actually cancel out the A's, which is perfect. And then we can find P. So we can do 50,000 divided by 30,000. That's just same as 50 over 32 equal to, the A's will cancel out, A divided by A, which is just 1. Then we have P to the 11 divided by P to the 4. We can take away powers when we're dividing here. So this will just be P to the power of 7. 11 minus 4 is 7. So this will be equal to P to the power of 7. So what we can do, just to find P, we can have P equal to the 7th root or maybe it might look a little bit nicer or easier in the calculator. P equals 50 over 32 to the power of 1 over 7. So plug that into your calculator. We have 50 divided by 32. Put it to the power of 1 over 7, or 1/7. This will give you, so what do they want it? They want P to 4 decimal places. So we want it to 4 decimal places. So we get that P equals 1.0658. 1.0658. So there's your value of P. Now they want us to show that A is approximately 24,800. So all we have to do is look at either equation. Let's look at equation 1 and plug in the value of P that we just found to find A. So what do we have? We have the 32,000 equals A times, so P is 1.0658, just making sure that's right, yep, to the power of 4. Okay, so what we have to do is 32,000 divided by 1.0658, it's not a very neat 5 or an 8, to the power of 4 will be equal to A. So put that in your calculator, make sure you have the answer from before just to make things a little bit faster. That will give you your value of A to be 24,796.80. Let's leave it like that for now, because what we're trying to show, that's approximately 24,800. Well, £24,796.80. That is indeed approximately 24,800, which is perfect. Now let's continue on. We have B, with reference to the model, interpret the value of the constant A and the value of the constant P. Okay, so let's go through it step by step. So what do we have? We have that V equals A times P to the power of T. Okay, let's think. One of these tend to be the value at the start, okay? So we always want to take when T equals 0. This tends to be the case in these kind of modeling questions. So when T equals 0, we have P to the power of 0, which equals 1, right? So we have V equals A. So the value when T equals 0. So what is T equals 0? Let's remind ourselves, what is T? T is the number of years after it was first valued on the 1st of January 2001. So if T equals 0, this will be the value on the 1st of January 2001. So exactly that, the value equals A. So A is value of, you could say vintage car, of car on 1st Jan 2001. Now looking at what P is, so let's see what P is. So every year we multiply our value by P, right? Because we're increasing that power every time by 1 for each year after 2001. So what is it? P is the rate of increase in value each year after 2001. The key bit is the rate of increase in value. So each year after 2001, or we can say 1st of Jan if you want to be specific. But yeah, that is exactly what you need to do for part B. Nothing too tricky there. Let's continue on. Using the model, find the year during which the value of the car first exceeds £100,000. Okay, so what do we care about? We care about when V is larger than 100,000. So this will be when A, this will be really neat, A times P to the power of T is larger than 100,000. Okay, so we can use the values of A and P that we found before. So A was 24,800, that approximate value, multiplied by P, which we had to be, let's use the same value, 1.0568. Let's be very careful there, make sure we're using the right thing. We do have 1.0658, so that's our value of P, so 1.0658. And we want to see to the power of T when this is larger than 100,000. We're going to read the question carefully, but first we need to solve for T. So reading that question carefully, we're finding the year during which the value of the car first exceeds £100,000. So after we actually find the value of T, we're going to have to find the actual year. Because remember, it's years after 2001. They don't just want a generic value of T, they want us to tell the year during which exceeds £100,000. But step by step here, we're going to make T the subject of a formula. So first things first, let's divide over. We're going to divide over by 24,800. So that leaves us with 1.0658 to the power of T. We want this to be larger than 100,000 divided by 24,800. Slap it in the calc, that's short for calculator, which is 125 over 31. Now here's the thing, we have T. We want T to be the subject of a formula. But currently we have 1.0658 to the power of T. What can we do? Well, we know that when we have ln A to the power of B, we can rewrite this using our log rules as B ln A. That's exactly what we want to do here. We want to put that power to the front of that log in order to get T the subject of the formula. Because we can then divide by the natural log of 1.0658. Okay? So we take the natural log of both sides just to make this a little bit easier. So we have t, or just to do it. So then we have t to the power, t le 1.0658 must be larger than the natural log of 125 over 31, taking the natural log of both sides and using those log rules. From here, we have that t must be larger than the natural log of 125 over 31, and we must divide that by the natural log of 1.0658. So from here, we have that t must be larger than, put it in your calculator, so we have the natural log of 125 over 31. We're going to divide that by the natural log of 1.0658. Be very careful when doing this in your calculator. This gets you that t must be larger than 21.88. So t must be larger than 21.88, but let's remember, t is the years after, so it's the years after 1st Jan 2001. So let's put I should have wrote 1st Jan 2001. Okay, so we're 21.88 years after the 1st of Jan 2001. Now here's the thing, let's look back at the question. They won the first year during which the value of the car first exceeds £100,000. So it exceeds £100,000 on that 21st year after 2001. So 21 years after 2001 is going to be 2022. And then we're going to be 0.88 through that year when we first get over £100,000. They don't want the first full year where we're over £100,000. That would be 2023. Here they're asking which year during we exceed 100,000, and that would just be 2022 because it's 21.88 years after 2001. We first exceed £100,000 in 2022. I believe that's all they want. Just make sure. First exceeds £100,000, find the year 2022. Perfect. And that is question 12. On to 13. Alright, question 13, a little bit of integration. We have to show that the definite integral, upper limit 2, lower limit 0, of 2x multiplied by the square root of x plus 2, integrating with respect to x, equals 32 over 15, 2 plus root 2. Now, you can either do this by parts, or you can do it by sub. They don't give you the sub, so this could make it a little bit awkward if you're not comfortable with it, but let's go step by step. So I'm going to go sub first, and then I'm going to do it by parts, just to show you both ways work. So when I'm thinking what substitution to make, I'm looking at which part of the integral annoys me the most. It would have to be that square root of x plus 2. So that's the substitution that I'm going to make. So in that substitution, we have that u equals the square root of x plus 2. So what do we have to do when we do integration by substitution? Change the limits, change the dx to a du, and make any subs that we can to eliminate those x's within the integral. So first thing I'm going to do, I'm going to change those limits. I don't really like seeing those limits in terms of x. So we have that x equals 2. So we know that u equals the square root of 2 plus 2. So we're going to have that u equals the square root of 4. So we have that u equals 2. So our upper limit is actually still 2. Looking at our lower limit, we plug in x equals 0. So we have that u equals the square root of 0 plus 2. So we have that u equals root 2 as a lower limit. So I'm already actually going to write out the full integral, as in just so we can start filling in the gaps as we go. So our upper limit will still be 2, our lower limit will be root 2. So next step, I want to change that dx to du. So we have u equals the square root of x plus 2, but what I want to do, square both sides just to make the differentiation a little bit easier. So we're going to have u squared equals x plus 2. Remember, when differentiating u, because we're doing du dx, the same thing with implicit differentiation, or is implicitly differentiating, but like when we differentiate a function of y, we multiply it by dy dx. So when we differentiate a function of u, we multiply it by du dx. So differentiating, we have 2u multiplied by du dx. Actually, let's write this a little bit nicer. We have 2u multiplied by du dx equal to, differentiating x is just 1, and the constant disappears. But we want dx to be the subject because we want a substitution for dx. So all we have to do is multiply over by dx. So we have that 2u multiplied by du equals dx. So dx equals 2u du. You can already write that in. 2u du instead of dx. Perfect. What do we also know? We know that the square root of x plus 2 will be equal to u. So we can also write that in right now. Let's draw some brackets in to make it very clear. So we have that. So what have we done? We changed the dx, we changed the limits, changed the square root of x plus 2 to be u. Now we need to find x, right? So what do we know? We know that u squared equals x plus 2. We want to make the x the subject of the formula. So we have that x equals u squared minus 2, right? So we have 2 times u squared minus 2. So don't forget that 2 at the front. Then we have u squared minus 2. So from here, we can actually start doing a little bit of integration. So what we have to do is a little bit of expansion here. We have u squared. First thing I'm going to do, let's do 2 times u times 2u. Let's just expand all those single terms first, right? So definite integral, upper limit 2, lower limit root 2. 2 times u is 2u. Multiply that by 2u. We're going to get 4u squared That's going to be multiplied by u squared minus 2 integrating with respect to u. So then we just expand this out. We're slowly getting to a polynomial, which is always lovely to integrate. So we have 4u squared multiplied by u squared. So that's just going to be 4u to the power of 4. It's going to be take away 2 times 4, so that's minus 8u squared. So now we can actually just integrate it. Raise that power up by 1, divide by the new power. So let's go through step by step. Raise that power up by 1. We're going to have u to the 5 divided by the 5. So we have 4/5 u to the 5. So that's 4 over 5 u to the 5. It's going to be take away. Raise that power up by 1 to get 3. So u squared u cubed divided by 3. So we have minus 8 over 3 u cubed. So that's minus 8 over 3 u cubed. From here, what are the limits we had to plug in? It was 2 and root 2. So nothing scary here. You just got to plug in these limits. Start with the upper limit. So 2 to the power of 5 is 32. 32, I believe. Let me just check everything in my calculator. Don't want to be making silly mistakes. 32. Answer times by 4. So that's 128 over 5. So we have 128 over 5. And we're going to be taking away 2 cubed is 8. So 8 times 8, that's 64 over 3. So that's what we get when we plug in 2. Now plugging in root 2. Now if you plug in root 2 to the power of 5 in your calculator, you get a disgusting decimal number, which we don't want it. So you actually have to manually do this. So think about it. If we have root 2 times by root 2, times by root 2, times by root 2, times by root 2. I know this is a little bit long, but I just want to make this very clear. So we can see that these root 2's times the root 2, actually that's not very nice, let's highlight it. We can see that the root 2 times the root 2 will just be 2. And we can see root 2 times root 2 again will just be 2, right? So we have 2 times 2, it's going to be 4. And I'm going to multiply by another root 2, okay? So multiply that by another root 2 will give us 4 root 2. So we have 4 root 2 multiplied by 4 over 5. So that's going to be 16, so 4 times 4, 16 root 2 over 5. That's going to be take away 8 over 3 times by u cubed. So same idea, we have root 2 times root 2 will be 2, multiplied by another root 2, so we have 2 root 2. 2 root 2 times 8 over 3, that's going to be 16 root 2 over 3. It's not a very pleasant negative sign. Let's make it look a little bit more normal. Okay, so now we're going to use the calc here, short for calculator. So we have 128 over 5, take away 64 over 3. So we have 64 over 15. That's looking quite good compared to what we're trying to get to in our answer. It's going to be take away 16 over 5 root 2 minus 16 over 3 root 2. We can almost just factor out the root 2's essentially. Let's just think about it. So we have 16 over 5, take away 16 over 3. So that's minus 32 over 15. So we actually have minus 32 over 15 root 2. You see I was very careful to redraw my brackets in. So we have minus minus. You don't want to get those signs mixed up in these kind of questions. So we have 64 over 15 minus minus. So that's going to be plus. So we have plus 32 over 15 root 2. Okay, nothing bad there. So then from here, going back up, compare it to what we're trying to get to, we have to factor out 32 over 15, and we're hoping we get 2 plus root 2 in our answer. Let's see if it happens. So factoring out 32 over 15, we have 32 over 15. Then what do we have to times by 32 over 15 to get 64 over 15? It's indeed 2. And then factoring out of 32 over 15 times by root 2, we're just going to be left with root 2. So we have 32 over 15 multiplied by 2 plus root 2. And I believe that is exactly the answer that they want us to get. 32, yeah, 2 plus root 2. So that's your answer, doing it substitution. Now let's go on to doing it by parts. Okay, now doing question 13 by parts. I'm going to use Liddy, where we have leave, integrate, differentiate, integrate. This is just by parts without having to write out all your U's and V's. It's just a little bit faster, more efficient in the exam potentially. So we're going to have that 2x as our leave and differentiate term, and then we're going to have the square root of x plus 2 as our integrating term. So first thing first, before we even start the question, let's do a little bit neater. We are going to integrate the square root of x plus 2. But remember, when integrating, we're going to write it as x plus 2 to the power of a half. So we have x plus 2 to the power of a half. Integrating this, raise that power up by 1, divide by the new power, and also divide by the inside of the bracket differentiated. But differentiating x plus 2 is just 1, so we don't have to worry about that. Therefore, integrating this will get us x plus 2 to the power, raise that power up by 1, to the power of 3 over 2, divide by the new power, same as multiplying by 2/3. Okay, very nice. From there, don't worry about plus c's because we're using this within our definite integral. Okay, so let's start using Liddy. So we have square brackets because this is already the bit which we don't still have to integrate. We can already plug in our limits into this bit. So leave, integrate. So we have 2x multiplied by 2/3 multiplied by x plus 2 to the power of 3 over 2. Great, so we can actually already do 2x multiplied by 2/3. That's going to be 4 over 3x. So we have 4 over 3x multiplied by x plus 2 to the power of 3 over 2. Then we can already have our limits of 2 and 0. I'm going to be taking away the integral, upper limit 2, lower limit 0, of differentiate integrate, LIDI, differentiate integrate. So differentiating 2x, that is just going to be 2. I'm going to multiply this by 2/3 x plus 2 to the power of 3 over 2. So what we already found to be the integral of the square root of x plus 2. We can already multiply out that 2 multiplied by 2/3. That is just going to be 4 over 3. So we still have to integrate this. First things first, let's already plug in the limits on this left-hand side here. So we have 2 times 4 over 3. That's going to be 8 over 3. So we have 8 over 3 multiplied by 2 plus 2. So that's multiplied by 4 to the power of 3 over 2. Well, 4 to the power of 3 over 2, we already know what that is. That's going to be square root of 4 to get 2, cube it to get 8. So we actually have 8 over 3 multiplied by 8. So 8 over 3 multiplied by 8. We can already write that as 64 over 3. I would recommend to write out all your steps. I'm just trying to condense this, make it look a little bit nicer. So we do have 64 over 3. And then plugging in 0, we actually don't have to worry about plugging in 0 because we can see we plug in 0 into this x here. The whole thing will be multiplied by 0, so we don't have to worry about that. So we have 64 over 3, and be taking away the integral, upper limit 2, lower limit 0, of, actually we can already start integrating this, so we've already wrote it out. So integrating our right-hand side here. Actually, let's rewrite it out just to make it look very clear. So what did we have? We had 4 over 3 multiplied by x plus 2 to the power of 3 over 2. Okay. So from here, what can we do? We're going to integrate this. How do we integrate this? Raise that power up by 1, divide by the new power, and then divide by inside the bracket differentiated. Inside the bracket differentiated is just 1. Don't worry about that. So what do we have? We have 64 over 3. Take away. We have to plug in some limits here. We have 4 over 3 multiplied by, so we're raising that power up by 1. So we have x plus 2 to the power of 5 over 2. Divide by the new power, so that's timesing by 2/5. Let's quickly rewrite that. 4/3 multiplied by 2/5. That's 8 over 15. So we have 8 over 15. And we still have to plug in the limits of 2 and 0. So let's go through that step by step. So we have 64 over 3, take away. So now plugging in 2, what do we have? Plugging in 2, we have 8 over 15. Let's write every step out. We have 8 over 15 multiplied by 2 plus 2, which is 4. 4 to the power of 5 over 2. Let's make that look a little bit nicer. 4 to the power of 5 over 2. Okay, then we're going to be taking away, plugging in 0. This is 8 over 15 multiplied by 0 plus 2 is just 2. This is 2 to the power of 5 over 2. So we can already see this is where our root 2 is going to be coming from. So step by step, guys, step by step, make it look very clear. Writing it out once again, we have 64 over 3, take away. So 4 to the power of 5 over 2, you can put it in your calculator or you can square root it. And then to the power of 5, so that's 2 to the power of 5, which is 32. So we have 32 times 8 over 15. I'm putting it in the calc. So what was that? That was 32 multiplied by 8. So that's 256. Answer divided by 15. So that's 256 over 15. So we have 256 over 15. And then we have minus 8 over 15 multiplied by 2 to the power of 5 over 2. 2 to the power of 5 over 2 is actually root 2 to the power of 5, which we had before when we were doing it by sub. So 2 to the power of 5 over 2 is root 2 to the power of 5, as we just said. So that's minus 8 over 15 root 2 to the power of 5. So root 2 to the power of 5, as we established before, is 4 root 2. Okay, so I'm just going to keep on rewriting this just to make it very, very clear, not to confuse any steps. You don't want to make any silly mistakes in these kind of questions. So 256 over 15 minus, so what is that? Root 2 to the power of 5, 4 root 2. So 4 root 2, 4 times 8 is 32. So we have minus 32 over 15 root 2. So what do we have here? We have 64 over 3, take away 256 over 15. Put in the calc, 64 over 3 minus 256 over 15 gets us 64 over 15. So we have 64 over 15, and then we have minus 32 over 15 root 2. So we have plus 32 over 15 root 2. Now, compared to our answer, what are we trying to get to? We are trying to get to 2 plus root 2, factoring out 32 over 15. So let's do it. Factor out 32 over 15. I feel like we've been here before. 32 over 15, so we have 2 plus root 2. And that's our answer, doing it by parts, or LIDI, which is just a more efficient way. And that's it. On to question, I believe the last question On to question 14. Okay, last question of the paper, question 14, a little bit of parametric equations. We're told the curve C has parametric equations x equals 3 plus 2 sine t and y equals 4 plus 2 cos 2t, where t must be larger than or equal to 0 or less than, or where we go, or less than 2. So this is very important, especially when we see we're going to have to sketch later on, because we're going to have a restriction on t, so this is very important. So part A of this question, we have to show that all points on C satisfy the equation y equals 6 minus x minus 3 squared, okay? So we're trying to find the Cartesian equation given parametric equations. So what we're trying to do, we're trying to eliminate all t's. We only want stuff in terms of x and y. So quickly just rewriting our equations, we have that x equals 3 plus 2 sine t, 2 sine t. Then we have that y equals 4 plus 2 cos 2t. Now in these kind of questions, sometimes they want you to link them by, for example, a trigonometric identity. However, in this case, we know we can actually write, using a cos double angle ID, we can write cos 2t in terms of sine t. So this will be able, we'll be able to use our x parametric equation, rearrange for sine t, and then sub it in. Let's go through that step by step. So we know cos 2t, double angle ID for cos 2t. There's three different ways we can write it. But the one that we care about, to get everything in terms of sine, would be 1 minus 2 sine squared t. We also know the double angle ID can be 2 cos squared t minus 1 or cos squared t minus sine squared t. But we only care about this one because it has everything in terms of sine, so we can now use our x parametric equation. Now looking at our x parametric equation, we can make sine t the subject of a formula and then sub that in into our y equation. So let's write out both equations very clearly. So rearranging our x parametric equation to make sine t the subject, we simply have x, we take away the 3, divide over by 2, and this will be equal to sine t. Great. Now looking at our y, we're now going to rewrite at cos 2t as 1 minus 2 sine squared t. Okay, so we have y equals 4 plus 2 times 1 minus 2 sine squared t. Okay, so this is quite good. So we know that sine t is equal to x minus 3 over 2. So now we can actually make that substitution into a y parametric equation to eliminate all of our t's. So this is perfect. So rewriting our y parametric equation, we have that y equals 4 plus 2 times 1 minus. Now instead of 2 times sine squared t, we have 2 times x minus 3 over 2 all squared. Because that is sine t, as we found that sine t equals x minus 3 over 2. So that's perfect there. What can we do now? Well, let's expand out the brackets. So we have that y equals 4 plus 2 minus, so 2 times 2, that's going to be 4, minus 4 times, we have x minus 3 squared on the numerator, and then 2 squared on the denominator will just be 4. So we can actually see that these 4's will indeed cancel out. So what are we left with? We're left with y equals 4 plus 2 is 6, take away, and then we just left, with the numerator. So we're just left with x minus 3 squared. And I believe, so we have y equals 6 minus x minus 3 squared. That's exactly what we had to show. So that is part A. Nothing too tricky. On to part B. Okay, so moving on to part B of this question. For part BI, we have to sketch the curve C. So we're sketching the curve C. What do we care about? So we're going to move back to that important highlighted piece of information that t, the restriction of t, must be larger than or equal to 0 or less than 2 pi. So when sketching any curve, like in function questions, what do we care about? We care about the domain, and then we also care about the range. Yeah, these are the two things we care about when sketching curves. So first things first, let's find the domain and the range given our restriction on t. So focusing on the domain first, domain being the x values. So what do we know? X equals 3 plus 2 sine t. So let's focus on that first. So looking at domain, we have that x equals 3 plus 2 sine t. And then we also have the restriction that t must be larger than or equal to 0, but less than 2 pi. So just a quick sketch of our sine graph, really quick sketch. We can see in between values of 0 and 2 pi, we do indeed achieve the maximum value of 1 and the value of minus 1. So what do we know? We know, just going step by step, that sine t can be less than or equal to 1, but larger than or equal to minus 1. So it can indeed achieve the minimum and maximum values that our sine function can achieve. So that's good. So from here, what can we do? We're going to try and make it look like our x parametric equation. So what we're going to do, multiply both sides by, or multiply every side by 2. So we have that 2 sine t, just comparing it to that x parametric equation, must be less than or equal to 2, and larger than or equal to minus 2. Now we're going to add 3 to both sides. So we have that 3 plus, just zooming in a little, plus 2 sine t, must be less than or equal to 5, and larger than or equal, so add 3 to minus 2, which is going to be 1. And we know that 3 plus 2 sine t is indeed x. So we have that x must be less than or equal to 5, or larger than and equal, and larger than or equal to 1. So that's actually a restriction of our domain when sketching the curve. Okay, now let's focus on the range. Absolute same idea. Let's remind ourselves of that y parametric equation. We have that y equals, going all the way up, equals 4 plus 2 cos 2t. Okay, so we have 4 plus 2 cos 2t. So this is good. From here, we also know, same restriction on t must be larger than or equal to 0, less than 2 pi. Okay, so quick sketch of that cos graph. Once again, like we did the sine graph, you can probably do this bit or skip this bit or do it very quickly, but just to confirm everything that we're doing, we can see in between 0 and 2 pi, we can indeed reach the maximum value of 1 and the minimum value of minus. So what do we know? We know that cos 2t will be less than or equal to 1 or larger than or equal to minus 1. Okay, great. So we want to make it look like this y parametric equation to find the actual range of our curve C. Okay, so the possible y values that we can achieve. So multiply both sides by 2, we have 2 cos 2t, just trying to make it look like what we have in that parametric equation. Less than or equal to 2, larger than or equal to minus 2. Now we're going to add 4, so we have 4 plus 2 cos 2t. 4 plus 2 cos 2t, adding 4 to both sides, less than or equal to 6, larger than or equal to 2. So therefore, what do we have as our range? Y must be larger than or equal to 2, and less than or equal to 6. Okay, so we can actually start getting somewhere here. We have our range. Maybe I'll highlight it, or let's just give it a little underline potentially like this. And then we also have our domain here. So just to make those very, very clear. So what can we do? Let's just draw out that graph as so what do we know? First of all, we know it's going to be a quadratic, right? 6 minus x minus 3 squared, right? So we're going to have an x squared, just expanding out that bracket. We don't need to do that, but we know it's going to be quadratic. I can actually write that here. It's going to be a quadratic. We know it's going to be a negative quadratic because it's minus x minus 3 squared, so we're going to have a minus x squared in that. Therefore, what do we know about the shape? We know our shape is going to be a frowny face, right? A negative quadratic, okay? We also know the turning point. So what is the maximum possible value that we can get? The maximum possible value, we have 6, take away something squared. If we want the maximum possible value, we want to take away the smallest possible number from 6, right? And the smallest possible number that you can get on anything squared, because we know that anything squared, just focusing on the squared part, it must be larger than or equal to 0. So the smallest possible value will be 0, right? Because we want the maximum possible value of y, so we want to do 6, take away the smallest value of this x minus 3 squared will be 0. So we know our turning point will be 6, or our y value will be 6. When? So when does this equal 0? That's when x equals 3. So this is like just completing the square and finding the turning point. So we have 3, 6 to be the turning point of this negative quadratic. So we already know. What do we know? We know that the mean is from x equals 1 to x equals 5. At 3, we have a turning point at y equals 6. So we can draw that on here. Next thing we can do is we can actually find the values of x when we have x equals 1 and x equals 5, okay? So just quickly writing it out, let's write it out just over here. We had that y, looking at the equation, the Cartesian that we found, y equals 6 minus x minus 3 squared, right? So y equals 6 minus x minus 3 squared. So if we plug in x equals 1, we have 6 minus, so that's 1 minus 3 is 2. 2 squared is 4, 6 minus 4 is 2, right? So when x equals 1, y equals 2. And then when x equals 5, this is quite rough, guys, just hoping this makes sense. When x equals 5, we have 5 minus 3 in the brackets, which is 2. 2 squared is 4. 6 minus 4, once again 2. So we know at the point x equals 1 and x equals 5, our y value will be 2. And then from here, we can actually just draw this symmetric negative quadratic graph. I'm going to do my best here to make it look all right. It's a little bit pointy, not very smooth, but you get the idea. That is indeed all we have to write down. So we have our turning point at 3, 6. And then we have, because of the restriction on the domain, due to the restriction of t, we have points at 1, 2 and 5, 2. And that's exactly what we have to do to sketch the curve C. Now, I believe there's a second part, exactly that. Explain briefly why C does not include all points of y equals 6 minus x minus 3 squared. I'm actually just going to write it here to save space. So we can simply say, why does it not include all points? Because we have that restriction. We have the restriction on t, we have that t must be larger than or equal to 0 or less than 2 pi, restricting the domain, sorry. So restricting domain, something like that. That's the key idea. The key thing is that we have that restriction on t, okay, given in the question. That's very, very important. So now moving on to part C. Okay, so on to part C, we're told the line of equation x plus y equals k. I've turned my brightness up, guys, where k is a constant, intersects C at 2 distinct points. State the range of values of k, writing our answer in set notation. Right, so we have some line of equation x plus y equals k. I redrew the curve to look a little bit smoother, guys, but there we go. So what do we have? So I'll do this in red, do it in blue. So we have that y plus x equals k. Let's rewrite this as y equals mx plus c. So rewriting this as y equals mx plus c, we have y equals minus x plus k. So we need to find the values of k where this intersects. So this intersects at two distinct points, right? So these kind of questions, I would definitely recommend to look at the graph because we just drew the graph out in part B. So potentially it may help just to try and imagine what we're trying to find in this question. So we want the values of k where we intersect at two distinct points. So we have to intersect this quadratic at two distinct points. We have a negative gradient. We have a gradient of -1, y equals minus x plus k. So what are we going to have? Well, I can see the first time or the first place where we'll intersect at 2 points would be the line. We cross our curve naturally, and it'll be right at the bottom here, where we have that point of 5, 2. That's the first line. We're going to intersect this graph twice. And we're going to keep intersecting twice as we go up, right? As that y-intercept increases, we're still going to be intersecting at 2 points, aren't we? But this will continue all the way up until we have the line that is tangent to the curve. So we're going to have to find the values of k corresponding to each of these two lines. Let's go step by step though. Let's first find that bottom line the first time we intersect the curve at 2 points, because that's what we care about. Now, luckily, this actually isn't too bad. We already have a coordinate this line goes through, which is great. We have the coordinate of 5, 2, because we can see it has to go through this point, which we found before, of 5, 2. So this is great. So x equals 5, y equals 2. So we have 5, 2. We can simply plug this into our equation of y equals minus x plus k. So we have that 2 equals minus x, so it's minus 5 plus k, right? Add over the 5 to the left-hand side, we have that k equals 7 on this line. So what did we establish? When looking at this bottom line here, every line which has a y-intercept larger than, now we know it's 7, every line which has a y-intercept larger than 7 will indeed intersect our quadratic twice, right? So we can accept any k value larger than or equal to 7. Why is it also equal to? Because the current line, where we have that y-intercept to be 7, but we're currently going through that 0.52, is already intersecting twice. So this does satisfy what we need. Therefore, we can say that k must be or can be larger than or equal to 7. But however, we're going to have another restriction. We have to now find that line that is tangent to our quadratic. Okay? So let's look back up. So we want to find the line that is tangent to the quadratic. So we have the line y equals, once again, we have y equals minus x plus k. We're trying to find where this is tangent. I'm going to keep saying it, tangent to the quadratic. What do we think when we think tangent? It's going to intersect at one point. In other words, it will have one root. When you hear these things, you've got to be thinking discriminant. Our discriminant will be equal to 0. We're going to have one root. So what can we do? Let's look at the two that we have. So we have our quadratic, as we saw before, to be y equals 6 minus x minus 3 squared. So what do we have? We have y equals, let me show this on the screen, there we go, y equals 6 minus x minus 3 squared as the Cartesian equation for our quadratic. And then we also have that y equals minus x plus k. What are we trying to find? We're trying to find the values of k when our discriminant will be equal to 0. I'll say it again, because it will be tangent and will only intersect the curve at one point, in other words, one root. So we just make the substitution for y. We have the y equals minus x plus k, so let's write it all out. So we have that minus x plus k will now be equal to 6 minus x minus 3 squared. From here, what we can do, let's expand out those brackets first of all. So rewriting it once again, we have minus x plus k equals 6 minus, then we have x squared minus 6x plus 9, just expanding out those brackets. Let's make it even clearer. I'm going to keep writing out every step so we don't make any silly mistakes. 6 minus x squared plus 6x minus 9. Okay, let's get everything to one side so then we can use the discriminant. Remember, discriminant is going to remind, equals b squared minus 4ac. And we want this to be equal to 0 because we're trying to find a tangent. So going back here, let's bring the x squared to the left because we like to have a positive x squared, don't we? So we're going to have x squared. Take away the 6x, so it's going to be minus 7x. So that's minus x minus 6x. Then we're going to have 6. So we're going to take away 6. Then we're going to add 9. So that's going to be plus 3. So we're taking away 6 and adding 9. That's plus 3 plus k. Okay? And this is going to be equal to 0. Perfect. Now we can use the discriminant b squared minus 4ac. We're going to set that equal to 0. So what is b? b is minus 7. So minus 7 squared is just going to be 49. Taking away 4ac. So 4 times a is just 1, so we don't have to worry about it. So it's minus 4 times c is 3 plus k, and this will be equal to 0. Discriminant equal to 0, I'm going to keep saying it. So what do we have? We have 49, take away 4 times 3 is 12. Take away 4 times k minus 4k equals 0. So what do we have? We have 49 minus 12, that is 37. And then minus 4k equals 0. So we have 37 equals 4k. Therefore, the value of k, so the y-intercept of this tangent to our quadratic, k will be 37 over 4. But remember, what do we care, or like why do we care about this y-intercept? At this y-intercept, this is the first tangent line, or the first line of equation y equals minus x plus k, or plus 37 over 4, but we only intersect their quadratic once. Every y-intercept beneath this 37 over 4 will indeed intersect our curve twice, which is what we got. Let's go back up to the question we care about, where we intersect c at 2 points. So we're going to have to be strictly less than 34 over 7, I believe, 37 over 4. So that is the condition. K must be strictly less than 37 over 4, because at this point we're only intersecting once. Everything less, we do satisfy question C and intersect twice. So we have that K must be strictly less than 37 over 4. So what are the two conditions we have? I'll highlight it very quickly. We have that K must be larger than or equal to 7 and less than 37 over 4. So those are the two conditions. Now, I believe they wanted it in set notation, going back up very quickly. Write our answer in set notation. Right, so set notation is nothing scary, guys. All we have to think about the unknown we've been trying to solve. So we go squiggly brackets. This just means the set of. Don't worry about too much about the meaning, but I'll explain it anyway. So this means the set of k. We care about the set of k. Colon. The colon just means such that. Yeah. So we care about the set of k's such that, and then we just write our inequality like normal. So we have that k must be larger than or equal to 7 and strictly less than 37 over 4 in order to intersect that curve C. I believe it was curve C twice. Quickly check that. Curve C, the negative quadratic. Yeah, intersect C at 2 distinct points. So we have in set notation the set of k's, squiggly brackets, such that, and then we just do our normal inequality. K is larger than or equal to 7 and less than 37 over 4. And that is 2018 paper 1. I hope this video was helpful.